Alright, number 6. We're given the displacement of our airplane is 599 meters. We're also given the y component is 89 meters. So to find the x component of the displacement, let's use Pythag. We'll use the y component, 89 squared, for A. This is what we're solving for, is the x component. So I'm going to put displacement x component squared here. That equals 599 squared. I've already got the math. Let's just subtract 89 squared. We'll work it out. Plug 599 squared minus 89 squared. We get 350,880. And this is equal to the x component of displacement squared. So take the square root of both. And d x component is 592.35 meters. So that's the first part of the problem. The second part of the problem asks the direction. So we know all sides of the triangle. Let's use, I'm going to use the inverse sine function, and we're solving for this angle right here. So let's make some room. Theta equals sine inverse, and that's opposite over hypothesis. Remember, so cut SOA. So is SOH. So theta equals sine inverse. The opposite of this angle would be 89 divided by our hypotenuse, 599. And we plug that in the calculator. We get 8.54 degrees. Now that's not enough. That's not telling us enough about direction. Since this is east, okay, our angle is going up above east. It's going to be 8.54 degrees north of east. All right, let's look at number 7. We're given the initial displacement for our railroad tracks, 478 kilometers. We're also given the y component of displacement, which is 42 kilometers. What the question's asking is for the western component, which is our x component, as well as the direction, which we'll use theta. So to find this component, let's just use Pythag. A squared plus b squared equals c squared. 42 squared plus x component of displacement squared equals 478 squared. We'll subtract 42 squared. And d x component squared is equal to 226,720. Let's take the square roots of both of those, and we'll get d x component as 476.15 kilometers. So there's the first portion. The second part is finding the direction. We'll solve for theta. I'm going to use the inverse sine function, which is opposite over hypotenuse, and that's equal to sine inverse. Opposite would be 42 divided by hypotenuse, which is the displacement, 478. And when we solve for that, we get 5.044 degrees. That's not enough. Since this is west, our angle is below west, it's going to be 5.04 degrees south of west. Okay, number 8's probably the longest question, but the simplest problem. They give you a lot of information you don't really need. The whole question is asking, what is the magnitude of the western component? We're given the displacement, 7,400 kilometers. We're also given the y component, 3,200 kilometers. So the western component is just the x component. So let's use Pythag to solve for x component of displacement. 3,200 squared plus x component squared equals 7,400 squared. We'll subtract 3,200 squared. These will cancel. Our x component of displacement squared equals 44,520,000. This is kilometers, but we'll get that next. To get it by itself, we have to take the square root of each, and the western component would be 6,672.33 kilometers. Okay, number 9 is a fun question. We have Valley Station and we have the peak of San Jacinto. The question asks, how high is this peak above sea level? Well, Valley Station is actually 0.80 kilometers above sea level. So we'll have to take that in consideration at the very end. We're given a displacement from Valley Station to the peak of 3.88 kilometers. We're also given the x component of that displacement, which is 3.44 kilometers. So what I'm going to do is I'm going to use Pythag. 3.44 squared plus the y component of displacement squared equals displacement squared. When we subtract this side from that side, we do both squares and subtract. dy squared is equal to 3.1519. To get this, the component y by itself, take the square root of each. The y component of displacement is equal to 1.77 kilometers. But that's not what the question's asking. We want to know how high above sea level the peak is. Since our y component only starts at 0.80 kilometers above, we need to add that additional 0.8 kilometers. And the answer is 2.57 kilometers above sea level. Number 10. We're given a displacement initially of 2.9 times 10 to the third, and this is kilometers. We're also given the x component, which is 2.8 times 10 to the third kilometers. So the question's asking, what is the y component, and then what's the direction? So to find the y component, let's use Pythag. We'll use 2.8 times 10 to the third. Let's go ahead and change that just to kilometers. 2.8 to the third, we'll move it over 3 places, and we'll just get 2,800, or 2,800 kilometers, plus y component, both these are squared, equals, this is 2,900 squared. We'll subtract 2,800 squared from 2,900 squared. This will cancel. The component y squared is equal to the square root 570,000. So we take square root of both. The subcomponent y is equal to 743.98 kilometers. Now, the angle. To find the direction, we must find the angle, theta. I'm going to use the inverse sine function. So theta equals sine inverse. And sine is opposite over hypotenuse. This is our angle. We'll use what we just found, 743.98, divided by hypotenuse, which is our initial displacement, which we converted to 2,900 kilometers. When we plug that in, we get 14.86 degrees. Now, because this is west, our angle is below west, this is going to be 14.86 degrees south of west.